So I'm going to preface this video by just telling you guys up front, my active board has been messing up lately, and so you may see it flicker once or twice on the screen. Not to be alarmed, hopefully it'll get fixed, but for this video you might see some flickering here and there. Okay, now that we are back, so for today what we're going to do is we're going to talk a little bit about pedigree analysis. And pedigree analysis is really not as complicated as a lot of people make it out to be. It just simply means that you are looking at your family tree, but more from a genetic standpoint, from how you inherit certain traits that you see in your family. And so it kind of looks something like this. This, what you see on this front page, is classified as a pedigree. Now, I'll just tell you up front, when you're looking at pedigrees, as you go further down, so as I go down the pedigree, I'm actually getting younger. So every line that you see here, we'll call this generation 1, 2, and 3. I'm actually looking at 3 generations in this pedigree. So if you would think about it, somebody up top could be like my grandparents, while somebody in the middle would be more like your parents or your uncles and aunts. And while you move down to the 3rd generation, this would be kind of like you, your siblings, your cousins, things like that. So as you go down the pedigree, you're always getting younger. As you go up, you get older. Now, as I said, your pedigree is really just a family tree. It's just some way to describe the relationships between your parents and you, or your grandparents and you, or your uncle and aunt and you. And usually we look at it for inheritance patterns of traits, oftentimes when we're looking at like genetic disorders. Or even, it doesn't have to be a disorder, it could just be any sort of genetic trait, blonde hair, blue-eyed, brown hair, green hair, whatever hair that you have. So now, when we're constructing our pedigrees, just so you guys are aware, there are a couple of rules of thumb, and there's a couple of ways that we indicate certain things in our pedigree. So for starts, every time that you see a circle, that's going to indicate a female or a girl of some kind. And if I see a male, okay, a male is always going to be represented by a square. Now, occasionally on very advanced pedigrees, you will see either a diamond or a triangle. I don't know, maybe this is a new age thing. There's a possibility in later pedigrees that this could mean something that's transgender or someone who's transgender, but typically what you see when you see a diamond or a triangle, this means unknown. Now, that sounds kind of silly. How would we not know? Well, think about it this way. Depending on when the pedigree was actually created, it could be that somebody was pregnant with a child, but they didn't know the sex of the child just yet. So what we would put as that unknown is like a triangle or a diamond or something to kind of indicate that the baby's coming, we just don't know what sex it is yet. All right. Also, when looking at pedigrees, it's important to kind of indicate twins, because twins are an interesting phenomena that not every family pedigree has. So when we see twins, it's important to indicate them as such. So for starts, the way that we're going to do it is we'll start out with fraternal twins. Now, fraternal twins, what you will see is you'll see a connection between 2 parents in this like open triangle kind of thing. Now, I'll just answer this right up front because I'm sure you're probably wondering, how did I know they were parents? Well, anything that's a circle connected in a line to a square, this usually indicates marriage or sexual relations, that they are with that person and will probably most likely have children with that person. And so that's usually where we see that. And anything that branches off from this connection is usually classified as children or offspring. So in the terms of fraternal twins, when we see this open triangle, that open triangle is what's representing fraternal twins, meaning that they are not identical, meaning they don't look alike. They could be a brother and a sister and a sister, a brother and a brother, whatever, but they're just fraternal in nature. Now, on the opposite end, the identical twins, they have a closed triangle between them and their siblings and their parents. That closed triangle is indicating to you that they are identical. Also, more things that you will see more often than not, like I said, any square that's being connected to a circle in a straight horizontal line, this is what's indicating marriage or a married couple or a couple that has somehow sexual relations with each other that will probably create children. And this pedigree that you see right here, this is actually a small one. This would be a pedigree for like an immediate family. So in the pedigree I have below, there are actually 5 people in that pedigree. We see mom and dad up at the top. So this would be mom, this is dad. And they have 3 children. 2 girls, By the way, guys, those of you guys who don't know, those are the symbols for female, and one boy. That's the symbol for male. So you have 2 girls and 1 boy. That's how many kids they had. So they had 3 kids, 5 people total in this pedigree. Like I said, pedigrees are not just family trees necessarily. They also show how do we create traits, or how do traits flow in this family? How do they get passed around? So we have a couple of other key indicators that you should be aware of. For starts, if somebody is affected with a genetic disorder or a trait of some kind, you will always see that circle or square completely blacked in. That means that they have that disease, or they have the disorder, or they have that trait. Now, if I see a circle with a dot in it, this means I'm usually an X-linked carrier. Now, the reason I'm a carrier and why I'm X-linked, any disorder that happens on the X chromosome is usually something that is X-linked, which is why they call it that X, because it's carried on the X chromosome. So think about girls. Girls always have 2 copies of an X if they're a girl or girl. So say somehow a girl is a carrier for some X-linked disorder. I don't know of any off the top of my head, so I'm going to make one up. I don't know if I'm right, but I'm going to say male pattern baldness is an X-linked trait. So say this girl, okay, is carrying this male pattern baldness trait. One of her chromosomes, if she's a carrier, is going to be affected. So I'm going to indicate the one that has the problem with a B. I could have indicated it, however. I could have even put a little asterisk at the top. Doesn't matter. I'm just showing you that one of those chromosomes has the problem. And that's what that dot is showing. It doesn't show that they're full-on affected. It just shows that they are carrying the disorder. All right? So that's what I mean by that. Now, autosomal carriers are usually indicated with a circle, because it's usually female, it could be male, doesn't matter. And it usually has one side shaded in. Sometimes you don't see it shaded in, it's okay. It's still, as long as you have that vertical line through it, it shows that it's a carrier. The next one is going to be something that is deceased. So usually when you're looking at pedigrees, if you look at a very extensive pedigree that goes back to like your great-grandparents or your great-great-grandparents or whoever's grandparents, most times they're going to be dead. So when we indicate that somebody is dead, we put a diagonal line through it to show them that they have been deceased. And the last one that you'll probably come across in some of your homework or your studies is this one that shows a female with a male connected via double line. And this shows incest. Incest simply means that this person is either married or has sexual relations with a cousin, a brother, a sister, an aunt, an uncle, something somewhere in the family they are connected. And so usually it's an incestual relationship. So we denote it by that double line through it. When looking at genetic disorders, the most common genetic disorders that we have are usually inherited by recessive or autosomal dominant disorders. So what do I mean by that? Well, I simply mean that if I'm said to be a dominant disorder, I'm going to just make notes up here. Dominant. Anything that is dominant means that it's going to have one copy of the gene. Only one copy to be potent. I don't know why my pen keeps skipping, excuse me. One copy to be potent. Meaning, if I had potent, I'm sorry guys, I don't know how to spell today. So if I had, say I was talking about it with like capital letters or something. Say I took the letter W. I would denote something as dominant with a capital. So my capital W, I could have 2 capital W's to show that that person is what we call homozygous dominant, which I'll talk about in a second. Or I could just have 1 W with a little w, which means they're heterozygous dominant. All right? Now, what do I mean by these terms homozygous, heterozygous, dyad, whatever? Let me talk about them. So here we go. Homozygous, meaning 2 copies. Okay? If I said to be homozygous, I have to have 2 copies. Homozygous always means 2 copies. If something is homo, like homosexuals, usually you're mating with the same type of person. Girls with girls or guys with guys. Homo. It has to mean the same copy for the traits. So when I see something that is going to be homozygous, if it's homozygous dominant, I should see 2 capital letters. I'm going to use W as an example. If it's homozygous recessive, I should see 2 little copies. That's homozygous recessive. It's the same copy, just done twice. Now, things that are said to be heterozygous, hetero means something that's different than you. So heterosexual couples means boys with girls. They're two different sexes. That's why they have two different things. Heterozygous means you'll have one copy of each. Usually heterozygous, usually as carriers for some sort of disorder. However, on occasion, heterozygous individuals can also be autosomal dominant, which we'll see here in a little bit how that happens. So let's look at this pedigree. Let's just look at this one for example. So looking at this pedigree, how am I going to determine that this is autosomal or it's X-linked? So go ahead and I'll give you a second. Think about it. Which one do you think it is, autosomal or X-linked? So you should have picked autosomal. And the reason it's autosomal, okay, is because X-linked disorders, like I said, it's related to the X chromosome. So in the instance here, if I have a woman, she has two X chromosomes. If one of them has a problem, okay, she's a carrier, that means that when she passes it on to her children, usually the people that are affected the most are males, because males only have one X. So say she has a 50-50 chance of passing her bad X to her son. And so if that son has the XB and then a Y chromosome, it's indefinitely going to get that disorder because it only has one chromosome and that chromosome is infected. On the other hand, if it was a girl, she could also be a carrier, like her mom, but that doesn't necessarily mean that she gets it. So usually, when you're looking at a pedigree, you'll see only circles that are, only circles or squares. It's going to be the squares that are going to be the affected ones. So you usually will only see squares shaded. Okay, so X-linked usually affect male offspring. All right, now let's look at this again. Let's look at another one. Oh, my bad. One more. Here we go. So this is the same pedigree that we just saw, except my question to you now is not is it X-linked or autosomal. Is this dominant or recessive? Is the pedigree dominant or recessive? So you should have selected dominant. And the reason that it is dominant is because a rule of thumb usually says, it's not always, but it's a rule of thumb, that pedigrees that have a dominant disorder or a dominant trait, you'll never see it skip a generation. So what do I mean by that? If I look down every single generation, I should see at least one person affected in that generation. It doesn't skip it. It always shows up in every generation. So dominant shows in every generation. All right. Now, with that said, let's look at this last one. Is this pedigree dominant or recessive? So you should have said recessive, and the reason for that is notice it doesn't skip a generation. So if I look at this, it does skip a generation, right? My bad. So if you look at the top generation, generation 1, notice how none of the parents have the disorder, but their offspring in generation 2 does. So it skipped a generation. So what I could say with recessive disorders is I could infer, depending on if it's dominant or recessive, I could infer that these parents that I see, they were carriers. Even though I didn't indicate it, I can infer that they were carriers. Because somehow, one of their kids got both of their copies that carry that disorder, and they got both of them in one, and made it recessive, all right, which caused that to be recessive. So I can infer that. So we'll say with recessive disorders, recessive skips a generation. generation. So let's look at a real life one. Now, if I looked at the pedigree for a widow's peak. So widow's peak, if you don't know what that is, that means the hairline goes down like at a peak. It creates a peak. While normal people who do not have a widow's peak, their hairline is just flat. It doesn't peak in the center. So looking at this pedigree, okay, I can determine just by looking at it if the widow peaks are autosomal dominant, autosomal recessive, or X-linked. So go ahead and try your hand at it, which one you think it is. So you should have selected autosomal dominant. Now the reason it's dominant, look at the pedigree. Notice that in every single generation, I see a widow's peak show up. Notice that it does not skip any generations. It's always there. It didn't skip it, so it's autosomal dominant. Now if you didn't get it from the shading, okay, you should have got it from the letters. Capital letters represent dominant. And notice that every person that has a capital letter has at least one capital letter that's affected with the widow's peak. So we say that it's autosomal dominant because they have to at least have one dominant or capital letter. But everybody else who doesn't have a widow's peak, they all have that recessive lowercase lettering, which you see here. They all have the lowercase lettering, okay? So affected people, they're going to have it, and the unaffected, they're not going to have a widow's peak. Same thing if we look at earlobes. So let's see, is this one autosomal dominant, recessive, or X-linked? Now looking at the pedigree, you should have seen it and say recessive. Now it's recessive because remember that rule of thumb. I said it skips generations. And if I look at this first generation, I notice that these two parents, these guys, created children in which two of their children have earlobes that are attached. Like here, these attached earlobes. You see that? So I found that they are recessive because of that. It skipped the generation. So I could have inferred that the first generation must have been carriers. Alright? And they eventually came together and two of their sons got earlobes that were attached. Now, if you didn't get it from that, you didn't get it from the shading, look at the letters. Sometimes you'll see letters. Notice how everybody who is affected have lowercase double f's. So they both have two copies of the lowercase f, meaning it's recessive. All right, so the final thing I just want to let you guys know is why is it so important not to mate with close relatives? So I know it seems unusual. We live in America. We know better than to mate with our brother or sister. We know better than to mate with our cousin. But there are plenty of cultures out there in the world today which do not abide by those rules. They do marry their first cousins. They do mate with their other relatives. And so what can happen is this thing called disorders and defects that are caused by recessive genes. Now, what do I mean by that? Every family, almost every single family, and if you take microbiology lab in college, you will know this. Every family usually carries a very rare disease in their family, but they don't realize that they have it because that rare disease is signature for just their family. And this rare disease is recessive in nature, meaning you have to have two copies of the gene for this disease in order for this disease to show up in your family. Now, most people in their family, they don't have the disease because they're not recessive for the disease. They're just carriers, meaning they have one copy of the gene that carries that disease. And so if it's very rare and it's very specific for your family, you don't have to worry about going anywhere else. If you mate outside of your family, if I mate with Joe Schmo down the street, okay, and he's not related to me anyway, I don't really have the likelihood of Joe Schmo having the same rare disease as I have that follows in my family. So I don't have to worry about Joe Schmo being a carrier for my disease that happens in my family. So my children will most likely not have this rare disease that I carry in my genetics. However, if Joe Schmo wasn't a stranger but was in fact my cousin, the likelihood of Joe Schmo having that carrier copy of that rare disease is really high. So I have a probability, about 25% chance, that my kid could have this really, really rare disease and be all messed up because I inbreeded. And so that term inbreeding is what we call when we marry or we mate with people that are closely related to us. So this is why it's bad. So that's pedigrees in a nutshell. If you are confused or you still need some help, by all means, please come and see me. I'll be happy to break down some pedigrees for you. You do have homework over this, so please make sure that you look over your homework and that you understand all of what it is asking you. If it doesn't, again, please come and see me. I'll be happy to help you.